Hi guys, going over the solutions to Learning Packet Problem 1. Hopefully in the past 10 minutes you've worked through this problem. Now I'd like to provide you the solutions for it. It says search the problem below and according to your flowchart, what equation will you use? Well, notice that we see the word bond here and we see the word bond here. So we're going to use the equation delta H equals the sum of the bonds broken minus the sum of the bonds formed. And when I say bonds, what I'm really referring to here is bond energy. Okay. How hard it is to break those bonds. Now notice there should be a 2 here. I really apologize, I keep making mistakes like that. So it says given the bond enthalpy data in the chart below, okay, so it takes 436 kilojoules to break that bond, 499 kilojoules to break that one, and 463 to break that one. This makes a lot of sense because of the pi bond there. Calculate delta H and add the energy value to the reaction above, and you'll see what I mean in a second. So delta H equals the sum of the broken minus the sum of the formed, and we know that the broken are the reactants and the formed are the products. Got to draw our Lewis structures in there to make it a little bit easier to see. Okay, so we have 2 hydrogen bonds, 1 oxygen-oxygen bond, and this actually is 4 OH bonds. Okay, so the broken, we have 2 times 436 plus 1 times 499, the formed minus 2 times 2 OHs at 463 each. And when you do this all out, you get negative 481 kilojoules per mole. It's really important to pay attention to this part right here because OH happens twice in H2O. So that's why you had 2 H2Os, but really 4 OH bonds. Is the reaction exothermic or endothermic? Okay, you guys know that. It's exothermic. Delta H equals negative 481 kilojoules per mole. Delta H is less than 0, thus it's exo. Add it to the above equation. Okay, well, reactions that are exothermic release heat. So the 481 needs to be on the product side. If it absorbed heat, the 481 would be on the reactant side. Now notice that the presence of the 481 over here is why its sign is negative. That negative means that it's on this side of the equation. And just write that down, and if that confuses you, we can go over that when I get over this stupid flu. What does the enthalpy value tell you about the bond energy of the products versus the reactants? Okay, so I want you to remember that when you had this reaction right here, H2 plus O2 goes to H2O, these are the reactants, these are the products, these are broken, these are formed. So if you go back to the notes that I gave you on this, you might remember that if the energy that is formed is greater than that which is broken, it's negative. So delta H is negative. Okay. That means that the bond energy of the OH bonds that are formed is greater than that which is broken due to the equation, which is broken minus formed. So if formed are the products, bond energy of the products is greater than the reactants. What is the free energy change equation we're going to use for this? Well, it's not electrochemistry. We're in thermodynamics, so it's going to be our good old equation, delta G equals delta H minus T delta S. Delta H is negative. What's the sign on delta S? Well, we go from two gases to a liquid, so that definitely gets cleaner. So delta S is negative. Plug these into the equation. What condition, high or low temperatures, would yield a spontaneous reaction? Okay, well, if you look on your chart that I gave you, this is going to be spontaneous at low temps. If you want to do it the other way, delta G equals negative minus T times a negative. That's going to be positive. When T goes to 0, delta G is going to be negative. When T is really high, delta G will be positive, which is non-spontaneous. But I just go to the chart. All right, guys. Hopefully I'll be back tomorrow. Take care.